Hey guys, welcome back to my YouTube channel. So in this video, I'll be doing an example of the central limit theorem and the strong law of large numbers problem in probability. A professor has 40 projects that will be graded in sequence. The times required to grade the 40 projects are independent with a distribution that has a mean of 10 minutes and a standard deviation of 4 minutes. Find the probability that the professor will grade at least 20 of the projects in the first 150 minutes of work. This is an example of a central limit theorem problem. So let me write down the formula for the central limit theorem. So we would denote x1 plus all the way to xn minus n minus mu over standard deviation times square root of n as n approaches infinity. Basically, let x1 all the way to xn be a sequence of independent and identically distributed random variables, each having a mean mu and a variance. So it would be this formula that tends to the standard normal distribution as n approaches infinity. So first, let xi be the time it takes to grade the projects. So let me write down. So what's given? So x would be I is equal to 1. Xi is the time to grade the first 20 exams. So let me also find the expectation. And that would be 20 times 10, which is just 200. And let me find the variance. So it would be 20 times 16. Because this is the standard deviation. If we're trying to find the variance, we're doing 4 squared. In that case, it would be 320. Since the professor will grade at least 20 exams in the first 150 minutes of work, if the time it takes to grade the first 20 exams is less than or equal to 150, then the probability that x is less than or equal to 150. So let me write down the probability that x is less than or equal to 150 is equal to the probability that x minus 200 over 320 is less than 150 minus 200 over square root of 320. With z being a standard normal random variable. So simplifying from here, so x is less than or equal to 150. That p would be z is less than or equal to negative 2.8. But this is the same as the probability that z is greater than or equal to 2.8. So this would be 1 minus this, using the z-score. And using the z-score, I would look up 2.8, so that would be 0.9974, and that is just 0.0026. The probability that x is less than or equal to 150 is 0.0026. So the probability that the instructor will grade at least 20 of the project in the first 150 minutes of work is 0.0026, or in other words, 0.26%. And this is an example of the central limit theorem problem in probability.